Now that you guys learned functions, conditional statements, and loops, I think you guys are ready to solve the next problem, which is about a variable. So in C, we're going to discuss about 3 different variables today. Those are local, static, and external. So let's begin. Local variable is created within a loop and also exists within the scope. So what I mean by scope is conditional statements and loops. So the lifespan of these variables are created on the call, okay? But then they are destroyed at the end of the function or end of the scope. And if these local variables are declared, so what I mean by that is if these variables do not point to a value initially, then they're just pointed to a garbage value. Let me show you some example codes. So below, we made some local variables that exist within the for loop. So within the for loop, I created a local variable called I and another one called square. So within the for loop, these values are constantly changed. We're incrementing them every single time. So at the last iteration, okay, I and square are destroyed after it leaves the loop. So as you can see below, I tried to print I and square, but the thing is I commented out because if we do not comment them out, then we're going to get an error. So yeah, so this is an example of local variable within loops. Here's another example. So I created a function, okay, and within the function I created another local variable. So I created a local variable called local var, okay. So in the main, I called the function, and after I called the function, I tried to call the variable. So I also comment that out as well because we're also going to get an error if we do print out local var. Let's talk about static local variables. In short, we just call them static variables. So static variables, they are created within the function and they persist between the calls. So let's dig deeper what that means. So it's only initialized only once. And the variable, it doesn't get destroyed when the function is done or the loop is done. It is destroyed when the program terminates. So the variable continues to maintain a state throughout the program. So let me show you a really small example how to use static. So as you can see, okay, I built a helper function called countCalls. And what this does is we are initializing a static variable called counter, and we're setting it to 0. So after it goes through the initialization, we are then incrementing that variable. And after we increment it, we're just simply printing it out. Okay? So now let's look at the whole program. So if we look at the entire program, if we look at the main, we are calling this helper function 3 times. So countCalls is called 3 times. So when we call countCalls the first time, we create the static variable called counter and we set equal to 0. Then we increment it. So from 0 it turns into 1. And then we're printing it. So counter is 1, right? So the output, it will say function call 1. Now, after we do it the first time, then we do it the second time. Now remember, counter was 1 when we printed out. So counter is still 1. So when we're calling this second initialization, this is ignored. And then we're diving straight into the second line, so counter. Remember, counter is equal to 1. So we are now incrementing that counter. Now it will be 2. So when we print this, it will print that counter is 2. So we have function call 2. And then we go back for the third time. And remember, this is ignored, okay, because we already initialized it already the first time. And counter is 2. So now we go to the second line, we increment it, then we print out that counter is not 2, but is now 3. So we have function call 3. So this is a really small example how we can use static variables. Now let's talk about the last one, and it is about external variables, also known as global variables. So global variable is declared outside of any of the function. If you only declare it, then it is initialized to be 0. So this is kind of different between the other variables that we've seen today, because in other variables, like the local variables, If we only declare it, it contains a garbage value. So the lifespan of these variables, the external variable, it begins when the program is created, and it is destroyed when the program terminates. So this is very different from the other variables that we've seen. They can be accessed and modified from any of the function and within the same file, and also because they exist throughout the entire program, whenever we access them and modify them, we need to be careful not to call them by mistake. Let me show you a very short C code. So on the screen, I created a global variable of integer type, and I called it global var, and I set equal to 5. And I created a helper function called modify global, and this sets the global var into 10. Now, if you look at the main function, there are two print statements, and I called the helper function in between. So what we're doing here is I'm printing out the global var before we modify it. And after we modify it, I'm printing the global var variable again. So if you look at the output, the original global variable is 5, and then after the modification, it says that the global variable is now 10. So this is a really small example of what an external variable does. So let me mention the key differences between the external variables and the previous variables like local variables. The key difference is that external variables, they exist within the file, and local variables, they only exist within the scope. So what I mean by scope is that they only exist within the function or within the loops or within the conditional statements, or you can also see it as within the curly brackets.